Shall we? I've started it, okay? So a little bit of revision as we just get into three type of functions we will be studying. The first one is known as a one-to-one or one-one function. This function, and we have discussed about all these things, so we'll just have a recap. This function is also known as a injective function. Injective function. So what does a one-one function mean? A one-one function means that if you have a function which is mapping from a set A to a set B, then you will have only one-to-one mapping. Means each image will have only one pre-image, and each domain will be mapped to one entity only in that codomain part. Okay, here children, there are some things you should understand. Look, try to understand this. So we just started. So this is just a recap of injective function. In an injective function, every element of the input or the domain should be mapped. Just try and see, every element of the domain is mapped to every distinct element in the, I call this as codomain. And this much portion will be known as my range. A range is always a subset of a codomain, right? And the language for this, we say, if a function f which is mapped from A to B is injective, okay, and we'll do some problems straight away now, is injective, that is, injective stands for 1, 1. Then we say for all x1 and x2 that belongs to A, for all x1 and x2 that belong to A, right? If fx1 has been found equal to fx2, implies, okay, children, try to understand, for all x1, x2 belonging to A, this is x1, this is x2, this is x3, each of them should have distinct mappings, fx2, fx3, okay? For all x1, x2, x3 belonging to A, if fx1, if you find that these two are equal, they cannot be equal. If these two are equal, then it is understood that these two are also equal. Clear? Okay. Implies x1 should be equal to x2. And this is the criteria that we will be using to solve any problem. So the question that we will get, is show, our question will be something like this: show that some function, say gx, is injective. Okay, we'll do problems a little bit at a higher grade than your book, then it will become easy. We'll get a problem where we have to show a function is injective. We will have two steps in that. We will say let x1 and x2 belong to A, and this function will be given to you. This function gx is such that it maps from A to B. This will be given to us. We will say let x1, x2 belong to A, okay, and then we will also say let fx1 be equal to fx2. We will assume this we will assume, and in our next step we will try to show that x1 is equal to x2. If we can establish this criteria, then we can prove that this function is injective. Have you understood? Ananya, clear at this place? We will be given a particular question. I think she's frozen. Ananya, am I live to you? Okay, we will be given a question where we have to prove a given function is injective. The only thing that we need to do is that we have to take an x1 and x2 that belongs to the domain, and we will assume that fx1 is equal to fx2. If we assume this, that is this, and we can create this criteria, that means the function is injective. Fine. Shall we take some problems? Okay, so let's take some problems. And so I got some problems. Okay, our first problem, though we did the other day, we'll do it again. So our first problem is there is a function f which is mapped from R to R, okay, and it says f of x is equal to e to the power x, and you have to show that this function is injective. Now before moving on like a parrot, let's get something clear. Do you understand what is the implication of R to R? R means real numbers to real numbers. R to R means, if you look at R R is something which is from negative infinity to positive infinity. Can you catch infinity? Never. So there always will be shown in circular brackets. Have you understood? In some problems, we will see R plus. R plus stands for all real numbers which are greater than 0. Greater than 0. So an R plus would be a closed-ended 0 to a positive infinity in this way. Means this side I can't catch, this side I can catch. R minus means it will be 0 closed end. No, R minus doesn't have 0. So our R minus would be 0 at this end, negative infinity at this end, both like this. You will be approaching 0, but you will not touch 0. Fine? 0 is taken as positive always. Is this much clear? Okay. So let's try to, and this chapter is all about writing skills. This chapter is all about writing skills. So let's solve this problem. So our step 1, right? So we go by step 1. What was step 1? You have to prove that. We say let x1 and x2 belong to R. R means the real number family. Okay? And let f of x1 be equal to f of x2. Fine? So we write f of x1 is equal to f of x2. Now you know how to substitute function. F of x is e to the power x. F of donkey is e to the power donkey. F of cat, e to the power cat. So f of x1 will be e to the power x1 equal to e to the power x2. All of you understood this step? Okay. Now we'll say taking natural log of both sides. Natural log of both sides. Natural logs antidote is exponential function. So you say ln of e to the power x1 is equal to ln of e to the power x2. ln and exponential are COVID and Covaxin. So what will be left? Just the patient. Patient is infected with COVID. You injected Covaxin. Now patient is free. So we will get x1 is equal to x2. Hence, proved that fx equal to e to the power x for f mapping from R to R is injective. The more you practice injective and onto, it becomes easy, because in bijection we have to prove both the categories, both the cases. Tell me, Ananya, was it Hebrew, Latin, or did you understand this one? Oh, you understood, right? Very good. How about you, Neha? Did you understand? We'll pick up our next question. Okay, shall we? Can I change the slide? Okay. Our next question is, we have a function g, and g as a function is mapping from z to z. What does z stands for? The set of integers, and integers are 0, 1, 2, 3 on positive side and -1, -2 on negative side. Okay, and the function is g of n is equal to 5n. G of n is equal to 5n. Right? So we'll use our same step. Now look at what is the independent variable n. So we'll take an n1 and an n2. Okay, so we start solution. We say let n1 and n2 belong to the integer family. Then we say let gn1 equals to gn2. Now what is the value of gn? Is 5n. G of cat, 5 cat. So 5n1 is equal to 5n2. What kiddo stuff, yeah. n1 is equal to n2. Thus, for g as a function mapping from z to z, given by g of n is equal to 5n is injective. Bacha, have you understood how to do? Very good. Intelligent children. Ananya, you are writing, right? Or only observing? Because I don't see the right shoulder moving. When a person writes, the right shoulder moves. As long as you are a right-handed person, if a left-handed, okay. Maths is very easy to see by the screen. Don't do that mistake ever. Okay, our next one. Next one is a little bit different. We have a question which says, f is a function that maps from R to R, real number to real number. Okay. And the function is given by f of x is equal to mod of x. Now we have to understand modulus function first, okay? Mod of x. Right. So before proceeding, let's understand this particular function first, which is the mod function. Mod function. Okay. Let's go by a basic process. What is mod of 5? 5. What is mod of negative 5? 5. Also known as absolute value. So in algebra, we define it as, we say if you ever get a function, f of x is equal to mod of x, this function can be broken into piece function, two pieces. Okay, it says that if your input x, if your input was x, which was anything greater than, first understand, then you write. If your input, what was my input here? 5. If your input is anything greater than or equal to 0, precisely it is telling that if you are entering a positive number, then retain the positive number. Have you understood? If you are entering a positive number, retain the positive number. However, if you are entering a negative number, then please take negative of the input. Then please take negative of the input. I entered negative 5. I took negative of negative 5, which is positive 5. Something understood? Okay. So based on that, let's try to solve this. So we say solution, let x1 and x2 belong to the real number family. And further we say fx1 be equal to fx2, which means mod of x1 is equal to mod of x2. Now here you will have two criteria. You can write x1 is equal to plus minus x2, or you can write x2 is equal to plus minus x1. Both criteria. Have you understood? Because mod can be plus minus also. Now this is not injective. Yeah. Plus minus. If you remove the modulus, what are your criteria? You tell me. Both were positive. Either one was negative. See, if it was a negative x1, still it will puke what? X1. Okay, let me say. The criteria from here, what do they boil down to? Either it can be an x1 equal to x1, oh sorry, x1 equal to x2, both positive. Either both can be negative. In this case, it is same as this. Or it can be one positive, one negative. Or it can be this one is negative and this one is positive. Nothing more than that. So actually, if you write this statement, this is more than enough. You don't need to write this at all. Now, can you say it is injective? No, it is not injective, because you are not landing up at x1 equal to x2, because positive x1 is equal to positive x2 is agreed. But positive x1 is again equal to negative x2. Two different relations we are getting. So we'll say, thus, we will say a function mapped from R to R given by f of x is equal to mod x is not injective. See, further you can see it in this manner. See, the mod function is like this. Your inputs are your input this time you have given is R. That means from negative R to positive R is your input. Anything that you give an input out here, your output will come what? Your output will always come in this manner. Even if you give a negative, you will get a positive output. Understood? So if you look at your codomain, this part is what? This part is a 0 to positive r, right? But your function was r to r. Instead of this, if your function was r to r plus, then it will be injective. Then it will be injective. You'll get all the positives. These don't get the negatives. Give me no. Here we will not have that criteria. No. Don't hold that. That will come in on to, not here. So sorry. This was whatever I have expressed here. This much is correct. So here, even if you give a positive, if you give a positive, you get a positive output. If you get negative, negative also a positive output. So this one can never be equal to the other. This is how we prove 1, 1. 1, 1 is very easy to prove. So you should know these two steps, and after that you do it. Clear? Shall we go to onto functions? Okay. Onto is something where people find it a little bit tricky, but it will become easy. Don't worry. So now next function is onto. Onto functions, which are also known as surjective functions. Surjective function. In crude language first. In crude language, f is a function which is mapped from a to b. F is a function which is mapped from a to b. Okay. Surjective function means every element of the codomain, must find a mapping to at least one or more than at least one. Means the codomain should be completely used up. Are you understanding? So this has to find a mapping here, right? This can be mapped to another one also. That's possible. At least one. This also has to have a mapping. This also has to have a mapping. This also has to have a mapping. The codomain is completely used up. Remember that in a surjective function you say the codomain. So we will first write the crude language. The crude language says every element of B, must find at least one, must find a mapping to at least one element of A. This is the crude language. So a little bit more interesting now. Every element of B such that that element is a small b, must find at least a mapping to one element of A such that A, based on which you can develop the relationship that f of A is equal to B. Okay. So one more easy language. Given an element B with B belonging to B, there must be an element A, where A belongs to A such that f of A is equal to B. The function value of A is equal to B. I try to absorb this definition. This is very important. Every element of B, the entire codomain must be used up. Every element of codomain must find at least one element of A to which it is mapped. Right? So our question will come what? Prove that this function is a onto function. Now how to solve that? How to solve a proof? And the technique that we learn usually works, doesn't mean that it works with everything, so you won't get a complicated one. Is this much fine? Okay. So our question would be given f is a function, say mapping from x to y. F is a function that maps x to y, and the function is given as f of x equal to y. f of x equal to y, prove that the function is onto. Onto means surjective. Okay, prove that the function is onto. So here, how will we prove it? We'll prove it in this manner. We'll say let y belong to, instead, if it gets a little bit confusing, let's say instead of x, fx, let's make it like this. F is a function which maps from a to b. Okay, and we say f of x is equal to y, say this way. Otherwise you'll get confused. So we'll say let y belong to b. Let y belong to b. Okay, and we will also assume y is equal to fx. We'll assume that. Let y belong to b, and we will find that this is our first step. Let y belong to b, and we will assume that y is equal to fx. We will then establish a relationship to obtain an x belonging to a such that f of x is equal to y. We will establish. Sir, how will you establish? That is what the trick is all about. That is what the trick is all about. ठीक है? Are we fine? Shall we pick up a problem now? Here, the more you do, the more you learn. So let's pick a problem. Once we do a process, remember the steps. So our first function is, our first question for onto is, f is a function mapped from z to 5 times of z. And the function is given by f of n, or you can write f of n or f of x. Let's say f of x is equal to 5x. This is the function. F of x equal to 5x. Prove that this function is a onto. You have to check whether this function is onto or not, surjective. So how do we do it? So we come with our step solution. Let y belong to 5z. Okay, let y belong to 5z. Okay, f of x is equal to 5x. You also know, children, that whenever we write f of x is equal to 5x, it simply means y is equal to 5x. This is same thing, right? Let y belong to 5z and let y be equal to 5z. So what you are doing in this step? You have actually taken your 5z set and you identified some arbitrary element y, which is belonging to this, as well as is the function value. Function is how much? 5z. So it's equal to 5, not 5z, 5x, sorry. The function is 5x. So y is equal to 5x. This much we have assumed. Right? This is an element y which belongs to 5z, and y is taken as the value as 5x. Our job will be to find one x to which it can be mapped, and if that can be done as a generic, the function becomes surjective. Yes or no? Yes. So my next step will be, or I write x is equal to y upon 5. Can I write this? Right? Now, you said that y is equal to 5 times, right? Y belongs to 5z, right? Y belongs to 5z. What does z stands for, beta? Z stands for an integer. This is all integers. This is 5 times of the integer. 5 times of an integer divided by 5 should also be an integer. Yes or no? Y is equal to this implies X belongs to Z as X is also an integer. Since Y by 5 is an integer. Need not write all this, I am writing for your clarification purpose. How did I conclude X belongs to Z? Because if this is an integer, the integer divided by, because you said Y is equal to 5X. Clear? Once X belongs to integer, okay children, now look at this figure. Look at this figure. I'll just correct it once again. So you are at this stage now. At 5Z you took one Y, and you took this Y is equal to 5X. Based on that, you could just trace one X which belongs to Z. You have still not done the mapping. You just traced an X and the X belongs to Z. Right? X belongs to Z means I can also write X belongs to domain. I am detailing it. इतना लिखने की जरूरत नहीं है. X belongs to domain implies that X can be used as an input. Do you agree or not? X can be used as an input to the function. X can be used as an input to the function. Are we fine at this stage? Okay. Oh. X can be used as an input to the function. Okay. Now, just see what we do after this. Okay. Now, what are you given? Your given function is f of x is equal to 5x. This is a function. This function is maps from where, beta? From Z to 5Z. You found an X which belongs to Z. So that value can be pushed into this function, right? So I can write, what is the value of X can be used? So I can write it as, instead of X, I can write f of y by 5 is equal to 5x. Can I not write this? Look, instead of X, I am writing y by 5. Okay. This function is f of x gives you 5x. Don't see the right side. F of dog, 5 times of dog. F of donkey, 5 times of donkey. F of y by 5, 5 times of y by 5. Very good. 5 times of y by 5. And this side we have 5x. Agreed? Look here. The given function is fx equal to 5x. Instead of x, I'm putting the value of x. I'm keeping the right hand same. 5 and 5 cancels. I get y is equal to 5x. I can now write y is equal to this 5x I'm changing with f of x. This 5x I'm changing with f of x. And I can further say that f of x is equal to y. Now just see. Did I arrive what I wanted to do? Given an onto function, try to find one y out here and try to establish an x such that f of x is equal to y. I said, let one y belong to this particular set. Agreed. And I said, let y be this function. Y belongs to this set means y has to obey this function. Y is equal to 5x. Based on that, I created an input for x. I created an expression for x, the best way. And then I check, does this expression make x an element of this set? Yes, it makes it. Because this set is all integers. I have an integer y, which is 5 times of an integer divided by 5. 5 times of an integer divided by 5 is an integer, which means x is an integer. Is that clear? If x is an integer, then x belongs to the z family. The z is nothing but the domain of this function. That means once you are the domain of this function, you are a legal input to the function. You can be used as an input. My job is done. So I write my function f of x is equal to 5x, and then I say that x can be used as an input. Exactly, I'm putting that input. I say that x can be used as an input, and I am exactly using that input here, because x is equal to y upon 5. Sir, where did you establish this? Here. And once you write x is f of x, I'm retaining the right side. The next step, I again read the function. F of x is 5 times of x. F of dog, 5 times of dog. F of cat, 5 times of cat. F of y by 5, 5 times of y by 5. 5 cancels. And what is this 5x? This 5x is nothing but f of x. And I just change my hands. And now go back to the definition of surjective. If I go back to the definition of surjective, it tells me that even from here or here, you say, given an element B, for your case, it was an element Y that belonged to 5Z. There must be one element X belonging to Z where you prove that f of x is equal to Y. If you have still not understood, you can ask again. Because you went for generic. You went by a generic case. You didn't take the value of x as some 5 or 3 or 4 or 6. You went generic. And by generic, you have proved it. And what does surjective say? Surjective says that give me one element in this set. I must find a mapping to at least one. Children, this way of proof is used usually in all universities and all. But this every time does not find a solution. Surjective, some surjectives are difficult to prove. But it usually works. This way, if you do, your clarity gets developed. Though few steps more, but nothing is pressed hard on you. You accept it wholeheartedly. If you're done with this, I can take another one example and we'll do the same way. Shall we? One more example, okay? What has happened to this? Okay. Chalo, our next problem for surjective. Our next problem for onto or surjective is f is a function that maps from real numbers to positive real numbers given by g of x is equal to e to the power x. Deliberately, I'm writing it like this so that you get confused. G of x is equal to e to the power x. What is the map? Achha, these all eggs and all, you need not draw these eggs. I am drawing that just to make yourself clear. You have a real number set, you have a real plus. What is real number means? Minus infinity to positive infinity. Here it is 0 to infinity. Okay? This is our mapping. So let's proceed. We have to check this function for onto. We have to check an onto, whether it is onto or not. So some basic things you should know, that's all. Let, so g of x, so we will say let y belong to r plus. Y belongs to r plus. Agreed? And y is equal to e to the power x. Clear? Y is equal to e to the power x. Okay. Now, taking, what is our job now? We have to create x. We have to create an expression for x. Such should be the expression that it should allow him a legal entry into this. That means you should create an x where you should be able to say that x is real number. X is real number, right? So let's see. Taking natural log of both sides. So it becomes ln of y is equal to ln of e to the power x. ठीक है बच्चा? ln of e to the power x. Now ln and e are COVID and Covaxin. So we can write now x is equal to ln y. Okay. Here we need to know something which you may not know. If y belongs to r plus, y belongs to r plus means y is either 0 or a positive number. Then natural log of that number is also a real number and it is positive. Ln y also is also a positive real number. Positive real number means it belongs to R. R plus is specific of R, but it belongs to R. So we can say X belongs to R. Have you understood? X belongs to R. If you say X belongs to R, so what did you do, children? You actually substituted, you actually took out some y out here and you said that this y is equal to e to the power x, right? By that way, you traced out some x out here, which is now a value which is equal to ln y, and that x is now inside here. Now we have to create the mapping, right? So x belongs to R, or x belongs to the domain, or x can be considered as an input to the function, right? So what is the function given? G of x is equal to e to the power x. This is your function. Now you are trying to input this x, but what is the value of x beta? G of ln y is equal to e to the power x, right? Okay, let's look at this function. G of x is e to the power x, g of dog e to the power dog, g of cat e to the power cat, g of ln y e to the power ln y. So on this side I will write e to the power ln y is equal to e to the power x. Clear? See, this side we are not disturbing, we are just disturbing this side. Now these are exponents. If bases are same, then exponents must be same. So can I now write, or ln of y is equal to x, because since bases are same, exponents must be same. Now you again take exponents of both sides. So if you take exponents of both sides, then this becomes y equal to e to the power x. Or from here itself we can take e to the power ln y means y. E to the power, in fact, itna karne ki zarurat hi nahi hai. From this step itself, did you understand this? E and ln are like antidotes to each other. So it becomes just y is equal to e to the power x. Okay. And e to the power x is equal to y is equal to g of x, or g of x is equal to y. So you can say that this function, now how will you write? G of x is equal to y. So you can now say, thus it is proved that gx equal to e to the power x for a function g that maps from r to plus r is onto. Children, if it is a dotted diagram, it is very easy. In 1 marks, you can get dotted diagram. Dotted diagram means, you know, the entire this thing should be used up and everything should have one mapping out here. No one should be left unused. Thus, it is proved that g of x is equal. How did you prove it? because we found a y that belongs to this, and for this we established a relation that f of x is equal to, sorry, g of x is equal to y. Clear? I'll try one more. Okay, one more. Now everything need not be proved in this manner, so I brought one more example, and let's see this example. Can I go ahead? Right. See, if you have to prove bijective, then you have to do both the steps. That is a little bit long. So let's look at this function. This is very stylish. F is a function mapped from real numbers. Sorry. F is a function that is mapped from real numbers to real numbers. And the function is given by f of x is equal to mod x. Now, this is a very tricky question. You did not do it. You did not sweat out that much like before. Now, what is your input? Let's look at our input. If you see the domain of this function, the domain of this function is minus infinity, okay, minus infinity to plus infinity. Do you agree or not? Right? If you see the codomain of this function, then the codomain is also minus infinity to plus infinity. Do you agree? Have you understood this much? Domain, codomain. But let's talk about the range. Let's talk about the range. What will be the range? Every time you do this, will you ever get a negative number? No, you won't never get a negative number. Your range is very stylish. It is only from 0 to positive infinity. Okay. That means if this is your codomain, there will be many positive entries. There is a 0 and there are many negative entries. Do you get it? However, you said that your range is only from 0, means only these fellows are going to find a mapping. What about these fellows? They have no mapping. But the definition of onto says that every element of the codomain must find at least one, which means that in an onto function, the range must be equal to codomain. This is a mandatory criteria for onto. But in this case, range and codomain are not equal. So nothing doing big steps. You can straight away say, since the range is not equal to the codomain, the function is not surjective. See, so stylish. Have you understood this? Your codomain is from positive to negative. Out here, I would be having a positive infinity, I have a negative infinity, but your mapping is only from 0 to. Inka kya karenge? They are not orphans. They did not find any mapping. As such, we will say that this function is not a onto function, or it is not a surjective function. So whenever you get something with modulus, you can go by this way. Generally, you get either with the EX, that means natural logarithm. We'll see one algebraic one also. Range and codomain must be equal. Shall we take one more problem? Okay, let's take one more problem. Okay, our next problem is, now this, let's do together. F is a function mapped from integer to integer given by f of x is equal to x minus 1. It's an algebraic function. You prove or check whether the function is onto or whether it is surjective or not. Are we fine? Shall we? So we write solution. Let y belong to the integer family. Y belong to the integer family. Let y be equal to x minus 1. Y be equal to x minus 1. Now what should be our job, Zoe? We should separate out x and create its credentials so that he can get an entry. So entry to where? Entry to where? Our mapping is now between z and another z. You have just taken one y which is equal to x minus 1. You now have to create an x so that the x gets inside. You have to give him permission to get here. So we write x is equal to how much? Y plus 1. Y is an integer. With an integer you are adding another integer, so you should get an integer. Or x belongs to z, or x belongs to domain. X belongs to domain. Is it getting easy now? So x can be taken as an input to the function. Now let's go to the function and do our job. So let's go to the function. What are we given? We are given f of x is equal to x minus 1. Now you are going to plug, instead of x, what will you plug? You will plug y plus 1 is equal to x minus 1, right? Okay, look here. F of donkey, donkey minus 1. F of y plus 1 minus 1. So here it will be y plus 1 minus 1. Y plus 1 takes the value of x is equal to x minus 1. Negative 1 takes away. So what do we get? We get y is equal to x minus 1. And what is x minus 1? Nothing but f of x. Or we write f of x is equal to y. Proved. Fx is equal to x minus 1 for f mapping between z to z is surjective. Here.
No,
no, but here you have assumed, see, you have assumed a y. Try to understand the story. Very good question. This particular z set has got many elements. Ananya, is this statement clear? Many elements. You picked up a random element y. And if y belongs to this set, it must obey the rules of this set. The rule of this set is that it has to be a value x minus 1. That does not give you any guarantee. Where have you created this image? You have to find its partner out here. This is image. Now you have to create a pre-image and you have to show that it is the function value of that. Right? From this step, Ananya, we came and we tried to identify an x. You just identified an x. That x is right now here. You identified. You have to first allow this x to enter here. To enter here, he has to satisfy the dynasty condition to be a member of this family. So he satisfied that he is an integer and he belongs to this family. Okay, he has gone inside. Our next step is, if he is from this family, then we should be able to plug him in this. We should be able to take him as an input. We took him as an input. And then we found out, oh, it's not only just one, it's actually the pre-image we created. Show me one y here. The definition is like this. Show me one y here. For this y, I should find an x, at least one x, whose function value is this y. Now, I would have been very happy if it was done here. I would have written less. All would have written less. Life would have been easy. Okay? But it's not like that. Clear? Okay. So we go now to bijective. We'll see a little bit about bijective function and see why bijective becomes important. Okay. Bijective. Bijective means a function which has to be both 1, and the function also has to be onto. That means it has to be injective and it has to be surjective also. A function which is 1, 1 as well as which is surjective is actually known as a bijective function. Okay, let's see. So we write a function f mapped between a to b, a to b, a to b is bijective if it is category 1 injective and category 2 surjective. And then we have to list out. Injective means for x1, x2, for all x1, x2 belonging to A, if fx1 is equal to fx2 implies x1 is equal to x2. You just proved it is injective, right? For let y belong to B, let y be equal to whatever it is, y belong to B, and then we have to say y belong to B, there must be at least one x belonging to A such that f of x is equal to y. Same thing. You can do bijective functions, some proofs on your own. I want to go and show you one important thing. What is the beauty of a bijective function? Okay. Shall I? Okay. Now see. Let's talk about our next chapter will be inverse trigonometric ratio. Let's talk about an inverse function. Okay. Let's have a function f which is mapped from A to B. What does this mean, children? A is my domain and B is my range or codomain, whatever you say. Range or is my codomain. Codomain. Whenever you say inverse of a function, then it is written as f inverse. Inverse of a function will be now mapped from B to A. So for the inverse function, my B becomes domain and my A will become range. Agreed? And this is the inverse function, f inverse. This is f. Okay. We say only functions which are bijective, and remember this very nicely, only functions which are bijective can have inverse, otherwise no. You will say, sir, how to prove it and all? Just by 2 diagrams we can prove it. Just by 2 diagrams. Okay. I'll do it in the next page. Is this thing clear? Okay. The next page I'm saying, if a function is bijective, only then its inverse exists. Wow. If a function is bijective, only then its inverse exists. So let's take a function f as a function mapped from A to B. Right? And case 1, let this function be only 1, 1. Only 1, 1. Means only injective, not surjective. Means this function is not bijective now. Okay? So this is A, this is B. How will the mapping be? This. Agreed? Now create its inverse, f inverse. How many out here? 1, 2, 3, 4, 5, 6. Right? 6. Let me call them as A, B, C, D, E, F, G. A, B, C, D, E, F, and G. And out here, how many? 1, 2, 3, 4, 5. Now, this is the inverse function. You created an inverse function, but your inverse function is such: A has a mapping, B has a mapping, C has a mapping, D, E. F and G has no mapping. If they are a part of domain, they are legal inputs. They should find. So this is not a function. Are you understanding? This is not a function. If it is a function, every member of the domain must find some mapping out here. This can be mapped to this one also. So a 1-1 function need not have, will never have an inverse. Because when you swap the case, then the validity of function is lost. Now let's check the case for if the function was only surjective. Say f is a function which is mapped from A to B, and we say it is onto only surjective, right? So see the mapping. Okay, this is A, this is B, and we will see generic mapping. Every element of B must have a mapping in at least one element of A. Where? At least one element means it can have more than one element of A also. At least one element. Possible? 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 This is a surjective function. Let's look at its inverse now. This is a surjective function, and we are trying to look at the inverse of this function. So how many? 1, 2, 3, 4, 5. I will not go further. The first itself is defeating the definition of function. In a function, an input cannot have two outputs. Sine 30 cannot have two values. See how beautiful mathematics is. It's not a function. Do you understand? So this function cannot have an inverse. So only functions which are on 1, 1 and onto. 1, 1 and onto. So let's create one 1, 1 and onto function. 1, 1 and onto. Huh? Plus x and minus x means? No, plus x minus x. First thing is, this is a relation. This is not a function. Do you remember? That was the first thing we said. In a relation, A can be to Ananya and Amit. But in a function, it is not allowed. Always see a function with a sine 30. Sine 30 cannot have two values. But a sine 0 can be 0 and a sine 180 can be 0. This is the function. So inverse to hoy nahi na. But we say what? Bijectives have inverse. So let's create a bijective function. Is this 1, 1? Yes. Is this onto? Yes. Swap it. Swap it. Is it a function? Yes. Bijectives only have an inverse. Sorry. F inverse. And if you want to see something interesting here, look, sine 30 is equal to half. You have read. Sine has an inverse. How do we write it? Sine inverse half is equal to 30 degree. Right? If this be the case, your brain should think like this. Sine x can always have an inverse function, which is sine inverse x. Right? That is what your brain is thinking now, which makes you think sine x is bijective. Otherwise, how can it have an inverse? As simple as that. Are you understanding the logic? Get into the debate. Sine 30 equal to half, sine inverse half equal to 30. This is what you have been reading like a Bible. Which means your brain thinks if sine x is a function, sine inverse is the inverse of sine x. This is our next chapter. That means you feel, acha, sin x has an inverse. That means sin x should be a bijective function. Means it should be a 1, 1 and on 2. Just see. So that means the sine function is bijective. So it's a 0. This is a pi by 2. This is a pi. This is a 3 pi by 2. And this is a 2 pi. Perfect. Okay. So the sine function will go like this and will go like this. This value is plus 1 and this value is minus 1. Right? So now the question arises, sine is not bijective because it is not a 1, 1 function. Because in this range, if I see, what do I see? I see that if for a 0, it is a 0. For a pi also, it is a 0. If this is sine. So it's not a 1, 1 function. It is not a 1, 1 function means it is not bijective. So it can't have inverse. But we do calculate inverse. So how do we calculate? We have to create what is known as some principal range of it. So how do we do it? There will be a negative. Oh, there has to be a negative pi by 2 out here, right? So, and there will be a negative pi out here. Have you understood? Now, we will take it here. And these ranges you have to remember in your next chapter. Now see. Now your function, now if you say my function is f of x is equal to sine x, and you are defining that x is an input which is greater than equal to negative pi by 2 and less than equal to pi by 2. Yes, this is called the principal range. Very good. Though you should understand how that principal range came. Now, if you see the function from here to here, only this much of the function. Is it 1, 1? Yes. Is it on 2? Yes, it is bijective. So the inverse of sine function is valid only in this range. Such ranges can be created here also. A similar range can be created here also, can be created here. So there will be many such ranges over which the function is bijective. मैं कौन सा लूं? Principal. Minus pi by 2 to pi by 2, then only the function will have an inverse. So whenever you go to inverse trigonometric ratio chapter and you write this sin x, they will be mentioning this. Without this, this is not valid. I am a good boy only when I am in my house. Outside, I am very notorious. But people say always, like your teachers tell you, your parents go and complain in school, she doesn't do her things. No, ma'am, she is a very responsible child because the teacher is observing you only in a principal range. And the mother is observing the child over this big range. Are you understanding? Isn't it interesting now? Why this thing comes? Now you can do this for the cost curve also. The cost curve will be starting from 1. And you can yourself create. Such we will do for the tan curve, cosec, sec, and the cot curve also. So I would say give a try to the 1.2 problems. They are much more easier than what we have done today. They are just like mappings are given, and mappings are very easy to do if the numbers are given, whether there's on 2 or 1, 1 or whatever. But this is your basic for your next chapter. In order for a function to have inverse, the function should be bijective. The next chapter is about inverse trigonometric ratios. But sir, trigonometric functions are not bijective. How are you creating their inverse? My child, I am creating a principal range on which I am making it bijective. And then I will do the problem out here. Enough. I have eaten your head for